All right, guys, welcome to another Advanced Refrigeration Podcast training video on the E2 controller. Today, we are going to be going over how to program a digital and variable speed compressor using Ultrasight and on the E2. So we're going to start on the E2 today. We're going to go into terminal modes. I can show you guys how to do it on the controller. Going to go ahead and log in. You need to make sure you're in level 4 login, whatever it is, if it's user pass or if it's already being finicky today. Okay, so we're going to set this up so we have a variable speed compressor or a digital compressor. So we're going to go to our suction group. So we're going to go to our suction group. And in this row, we have our compressors. If it's a digital, it'll say digital. If it's a VS, it'll say variable speed, it'll say variable speed. So we're going to go F5 to our setup. And we are going to scroll all the way over to the compressor setup screen. So first things first, we'll do a VS. So we're going to go on the compressor setup screen. We're going to go to whatever compressor it is. We're going to hit F4 lookup. Now you have a couple options here. You have compressor, unloader, which would be an unloader valve, VS, which would be a variable speed compressor using a VFD. You have a digital, which would be a digital compressor, and a CT drive, which would be an Emerson CT drive. So we're going to go down to VS. So now, when we hit the next tab, it's going to make a C9 appeared that wasn't there before. That's our variable speed menu. So we're going to come down here and we're going to go over a couple options. First things first, you have your variable alarm input. So your drive fail. So you're going to tie your drive fail to here. You're going to land it on an input board, and you're going to put your board point in here. Now, this is where things get kind of important. So you have your VS max speed. That needs to be at whatever the compressor RPMs are. So if it's 1800, 2600, whatever the compressor manufacturer states. So we'll say 2000 just for how it is. Now, I see this all the time with every major EMS company. They do this. I don't know why. It ends up making it run like crap. I don't know if they've all been shown this, but so VS increase rate and decrease rate. I see them at 1,000, 2,000, 4,000 all the time. They run like absolute crap like this. So I usually go 350 to 450 for the increase rate, and then decrease rate, I'll go 550. Now, this lets the drive slow down a little bit. It doesn't ramp up as fast. Now, you don't want it to ramp up as fast in the controller because it ends up fighting itself. You want a faster decrease rate than increase rate because otherwise you're going to have hunting. Now, VS fail mode, digital staged. I never really changed this, but you hit the question mark. Still help available, of course. So you hit look up. You could go lock on, lock off. So if it's failed, you could lock the compressor on or lock the compressor off, or digital staged. I usually leave it at digital staged, which means it'll turn the compressor on and off if it's if the suction group's controlling it, if it's in bypass. So reset count 3, usually don't ever change that. Reset interval 10 or 30 seconds, depending on what the customer states. 10 is fine. VS fail priority If you want to change it, you can. I usually leave it at 20. Okay, then you have VS in inverter reset out. So that's going to be your output for your inverter reset signal to your actual inverter. So your digital closure for your reset to reset the drive if there is an issue. Then you have inverter bypass out. So that inverter bypass out is going to be your bypass contactor if you have one. And then BS RPM is just going to be it's just a readable point. It's a writable point if you have a Emerson drive and you're doing that with it. Active variable capacity, again, you could use that to write to something if you needed to. Active variable percentage, same thing, use it to write to if you need to. Now VS lower percentage. This is where it comes into be important. So say you have a compressor that you could only go down to, say it's at 60. See, your compressor normally is at 60 hertz and you could only go to 30. So you would want to put that at 50%. So you could vary that compressor down to 50%. Now this matters for compressor manufacturer to compressor manufacturer. Carlisle, Copeland, Bitzer all have different set limits. Some are more, some are less. Some you could overspeed, like Carlisle screws. You could actually put them to like 75 hertz. So you get extra capacity out of them. Now it all depends on what the compressor manufacturer says. So this variable lower speed is going to be important. Now you're also going to have limits in the drive that are going to limit that RPM and ramp up rate, which are going to be important too, which we'll talk about in a second. But this is important. This sets your lower limit. And then variable percentage out, variable stage out 1 is going to be your analog signal from CPC, the 4AO board, to the actual drive. So that's going to be your analog signal. So we'll say board 1.1. I actually don't have an analog board, so I'll show you guys how to add one. Okay, so I added the board in. Now output type. If you hit look up right here. So you have VS compressor linear. Just leave it at VS compressor. You're going to name the board point. It is not going to let me in this screen. Okay, so your engineering units are going to be percentage. So I'll do it a different screen. So that's how you set up your board point. So now that this is all set up, we're going to hit the menu button. Yes, we want to save it. Okay, we're going to go we're going to go to input definition. I'm sorry, we're going to go to output definitions. We're going to output definitions. Now we need to set up the actual board point. So we go to 4AO board 1.1. We're going to go setup. So first things first, we're going to name it. So we'll call it 1.1. This is very important. Compressor 1 SIG. Now, under here where it says modify output equation, so high end point is on the left hand side you have your voltage range. On the right hand side you have your engineering percentages. So when the suction group is at 100%, it's going to be sending 10 volts. When the suction group is at 0%, it's going to be sending 0 volts. Now, so say if you wanted 0 volts at 50, so at 50%, when the suction group goes to 50%, it's going to send 0 volts. So if you want to do it that way, you could change your output equation depending on how it is. And then likewise, if you had a 10 to 0 volt drive, so at 10 volts, it's at 0%, and at 0 volts, it's at 100%, which is how it should be, because you always want to fail with refrigeration on. So that way, in your drive, you flip the signal. So when it's at 0 volts, the drive's at 100%. When you give it 10 volts, the drive's at 50% or 0%. However you want to do it. This all depends on how you're doing your control strategy. I generally do 10 to 0 for everything. So at 10 volts, it's at 0%. At 0 volts, it's at 100%. And I usually set my low limit in the drive. I'll say at 0 volts, the drive is off. At 10 volts, the drive's at 100%. And I'll set my scaling of the drive so that I can't go under a certain RPM. With a reciprocating compressor, you cannot go under a certain RPM because it's a constant torque motor. So it'll just get shaft stall and it won't be able to turn the pistons over. So that's very important. Same thing with your ramp up times. You need to be quick. 5 seconds, 10 seconds, no more than 10 seconds at ramp up time. Now that is all going to be in the drive is your ramp up time. So just make sure you set it in the drive. Copeland has a bulletin for it. Bitzer has a bulletin for it. I'm not sure about Carlisle. I believe they do, but just make sure your ramp up times are quick inside the drive settings themselves, and your minimums and maximums are set in the drive. Don't rely on the E2 to do it. You don't want to do that. You want to have everything set in the drive. So if somebody goes to override it in the E2, they don't break a compressor or stall it out or overamp it. You want everything to be done inside the drive for safety reasons. Now I'll show you guys this on the E2, or I'm sorry, in UltraSight. So we'll get out of here. We'll close terminal mode. We'll synchronize the site real quick. Since we did it in terminal mode, we got to sync it back to UltraSight. So, okay, we're going to go into rack A suction group. We're going to go to edit application. We're going to go to stage setup. Like same thing. Now you get your arrows that'll look up, change VS. We go to variable capacity. Everything's in here. So same things we had before. Board points, VS, max speed, increase, decrease rates, stage, digital, reset value, lower percentage, everything's in here. So that's just one thing. It's just easier to do it on UltraSight. So all the same menus. Now let's go over on how to do a digital compressor. So we'll go back into terminal mode. Okay, we got to log in because it logged us out. Okay, so we're going to go F1 to suction. Go down to our suction group. We're going to hit F5 for setup. Now we're going to go over to our stage setup. Okay, now we're going to hit look up. Now, it doesn't matter what compressor this is on because it's going to prioritize the VS or the digital compressor for whatever one it's on. So we're going to go down, we're going to choose digital. Now, again, like I said, the VS menu, it's going to populate another menu now. So now that we did digital, if we hit the next tab, it'll populate another menu. So C9 populated variable capacity. So you see on this one, we have about a quarter of the options. So now you have a couple options here. Active variable capacity, you can write that to whatever you need to or set it at the log. Same thing with the next one. So lower digital percentage. This matters on what compressor you're using. So a 3D or a 3D or a digital scroll is 10%. Now, certain digital scrolls, the low temps, they don't want you to go down to 10%. I've done it fine. I mean, if you have a lot of unloading, it may become a problem, but look up the IOM for whatever compressor you're using to make sure you have this right. 4D is 50%. You can only go down to 50% because you only unload one head. A 6D is only 66% because you only unload one head. So that lower digital percentage is very important. The digital period is 20 seconds for all the refrigeration compressors. When you get into HVAC compressors, the digital period changes. That's just how often the signal updates from the E2 to the actual IDCM controller. If you're using a Bitzer controller, you could change this. I've gone down to 10% on it and had very little issues. The new digital Bitzer compressors run awesome. They're actually able to unload all 4 or 3 heads on a 6-cylinder compressor or a 2-cylinder or a 2-headed compressor or a 3-headed compressor. So they can unload the whole compressor and they freewheel it. That's one of the advantages over the Bitzers have, and their new unloading board works great. So now down here, this dynamic minimum enable, I've never had to use it, so there's no help for it. So if you hit yes, we'll see if it populates anything. It does not. So I've never had to use a dynamic minimum enable, so I always leave it at no. So down here, you have your variable speed stage out, just like you would on the VFD. So this is the exact same. So if it's board 1.1, you put it as 1.1. If it's 1.2, you put it as 1.2. So whatever your analog output card is going to be. So that is exactly how you set up a digital. Now, this is where the digital gets different than the VS drive. So we're going to hit yes. We're going to go menu 7. We're going to go 2, which is output definitions. We're going to go down to our variable stage out 1. Okay, this is where the Copelands get messed up every single time. Okay, if you're using a 3D, or any of them, for example. So if it's a 3D or a scroll, so it's 1 volt and 5 volts, not 0 to 10. So high endpoint and high end engineering units, 5 volts equals 100%. 1 volt equals 0. So the way the controller does it, anytime the controller drops below 1.44 volts on the actual IDCM controller, it's going to lock out. So 10% of 1 to 5 volts is going to keep it at like 1.5 volts, just roughly above that 1.5 volts. That'll keep you at 10% and keep you from locking out. This is how this controller needs to be scaled. I see this all the time messed up. I see it 1.5 to 100. I see it 0 to 5. I see it 0 to 10 is the most common because nobody ever sets up the output after they set it up and they get nuisance alarms. Or if you set it up 0 to 10 and it goes 10% of 0 to 10, you're never going to fully unload that compressor. So that's where it gets messed up. Now, if it drops below 1.4 volts DC, it's going to lock out on that demand signal loss. So that's why it needs to be set 1 to 5 volts, 0 to 100% for the engineering units. Now, the E2 will take care of the scaling and it won't let it go below 10%. Now, the reason you want to set it up like this is if you have an emergency situation and the suction group needs to shut down, it will kill the compressor voltage, the DC voltage. It'll drop it to 0, which will cause that IDCM to go off on demand signal loss. Normally, if I'm putting one of these compressors in and retrofitting it, I make sure it has a compressor relay still on an ARO board to shut it down if there is a situation like this. But protocols, especially Hussmann, does not provide a relay for the digital compressors. They rely 100% on the variable signal to shut it off, which leads to issues with release blowing if they are not scaled properly, because when it goes to shut off, it will not give it it will not drop the supply voltage off, and the compressor won't shut off. Especially if you're in an Aldi and you're on the low temp group and a freezer, and they shut off the actual suction group when it goes into defrost because there's only one thing on the group, that digital compressor will keep running and it'll eventually burn out. I've seen it countless times at those stores where they're programmed wrong from the factory or programmed wrong from startup, and it's 0 to 10 volts. And when it goes to shut off, it doesn't drop the voltage low enough, and it just keeps the compressor running and burns out. So this analog scaling is very important. So if you click out of there, we'll go out and we'll site synchronize again. What am I doing here? And then we'll do it in, I'll show you guys an ultrasite where all the menus are. Okay, so we're gonna go to our enhanced suction. We're gonna right click, edit application. We're gonna go to stage setup, same thing. Now compressor 1 is a digital compressor. I tend to make it smaller, the variable speed, even if it's not. I tend to make it the smallest compressor, so that way it wants to run it more. You don't ever want all your capacities the same. You want the E2, even if you go 16, 17, 18, 19. You want the E2 to have different numbers. It allows it to have a choice. Otherwise, it tries to equal runtime on compressors, and you don't want that. You want it to have a choice of different compressors. I mean, it does this weird switch over thing where the PID doesn't know what to do. So you go to stage outs, you got all your outputs in here, and now you go to variable capacity. Same thing. That's where that lower digital is. Now say that you have a 4D with a digital. You're going to make that 50%. So with a 4D, that's going to make the voltage range 50% of 1 to 5 volts, which is going to make your lower percentage 3 volts. So if it goes any lower than 3 volts, it's going to lock the compressor out and demand signal loss. So that's why on a 4D, it's important to go 50%. Now, if you go, it's a 60, you're going to go 66% or whatever it equals out for that, because you don't ever want to drop that demand signal lower than that. With the Bitzers, theirs are 0 to 10 volts or 10 to 0 volts. It depends what card you have in there. If it's a CAR R2 digital unloading card, you could have a card that's down to 10%. You could have a card that's at 50%. You could have a card that is 0 to 10 or 10 to 0. It all depends what card you have. There's like 6 different cards. So it'll have like a program number on there. You need to pop the little memory card out of the Siemens controller and see what actual card you have in order to properly scale the output and do your lower percentage. It will not lock out like a Copeland will, because there's no alarm on that controller, but you won't get a good unloading from it. Now, their new controller is awesome. It's Bluetooth. You could hook your laptop up to it. You could tell it how many unloaders it has. Put the compressor model number in there. It automatically sets up how low it can unload to. Like I just did a set. It was 2 heads. It goes down to 10% capacity. It would unload both heads and basically freewheel the compressor. And you could change your unloading signal from 0 to 10 or 10 to 0, depending on what you had it on. Like obviously, we do 10 to 0 for just about everything. So when it's at no run, it's going to be 10 volts. Full run is going to be 0 volts. So that way that compressor will always run. And then you get a lot more feedback signals and logging out of that controller, but it all depends. Read the compressor book, read the manual to see what your signal is supposed to be. Carlisle has a digital compressor. I've only seen it on 3 or 4 stores. To be honest, they were kind of a disaster. Don't see them very often. Carlisle's you end up seeing on drives more. They seem to do better on drives. But same thing with theirs. They only had an alarm for high discharge temp, but again, there was a specific voltage range that it had to be set up for. Like that is the number one thing I see messed up on these compressors is the voltage range. So again, so if it's a 50%, if it's a 4D, and because it only unloads one head, it can only drop to 50%. That'll keep you with that 1 to 5 volt signal at 3 volts. It'll keep the signal from dropping. So that is how we do a variable speed compressor and digital compressor in the enhanced suction group. So thanks for watching, guys. Like and subscribe, and see you in the next one.